Okay, so welcome back. So here's another pretty cool example. So it says a medication is currently flowing at 80 milliliters per hour. A doctor has asked you to first increase the rate of medication flow by 15%. So we want to be increasing it up. After about 3 hours, the doctor has noticed that a decrease of medication is needed so that the flow becomes 55 milliliters per hour. By what rate would you have to decrease the medication by to obtain the desired flow? All right, so it looks like we have two. One is an decrease, and then one is an increase. Okay, so we have something like this. So what I like to do is I kind of look at these as increase or decrease problems. And so I'm going to set this up. So here's the given. We're looking for, I guess, the rate of decrease of that second. Okay, so we're going to try to find that. And when I set these up, I always kind of go like this. I always start with whatever it is that they give me. So this is the original flow. Okay, so it's flowing at 80 milliliters per hour. So that's the first piece. Now from here, you either increase or decrease this flow. Now they're saying we're going to be increasing the flow first by 15%. So that's the first thing that happens. Now 15% is 0.15. I'm going to keep it as decimals because for computations, that's what we need. And since it's a decrease, so again, so that would be 100% of the original minus the 15% decrease, or simply just 1 minus 0.15. So that's the, it's an increase. So let me put that back. So it's going to be a plus, okay, because of this increase right here. So now we've increased our medication. Now, after 3 hours, the doctor says, okay, so we're going to be decreasing the medication next. Now, if you're going to be decreasing the medication, so this is what it was, it was increased first. So it would have been more than 80 milliliters. But now the decrease, we don't know what this decrease is. So let's say, so that's going to be some kind of a rate of decrease. Okay, I'll put the D, okay, just to remind me that I'm working it out in decimal form. So, and because it's a decrease, now it's going to be 1 minus D, right? The 1 minus D comes from the fact that we have 100% of whatever, this would have came out to be, okay, after these two were kind of multiplied. And then we would be, minus whatever we are decreasing it by. All right, we don't know what this is. Now I've called this kind of D at the moment. But what I do know is they tell me that the medication after the decrease would have been 55 milliliters. So whatever I would have done, it would have given me 55 milliliters per hour. All right, so that's what I have there. So to find my answer now, so what I need is, because I'm trying to find that D. And in order to do that is because they give me how much it would be under the decrease. So it would have been all of this. And what you do is you just follow your path to the beginning. And I'm going to have to multiply all of these together, right? So as I multiply all of these together, so this will set up my kind of equation. Now, again, you can be kind to your teachers, maybe define what D is. So let D, okay, be the rate of decrease. You don't have to call it D, you can call it something else. Be the rate of decrease. I kept it as D instead of R just because of the fact that, it's a decimal, but I'm not always consistent even in that. You can certainly call it RD, okay, for rate of decrease. So this is what we were going to be looking for. So going from the back to the front. So this is 55 equals, and now we have 1 minus D multiplied by 1 plus 0.15, and then multiplied by 80. Okay, so that's just coming straight from that little branching pattern that you have there because you're just multiplying them out. So notice the 80. So first, if you just multiply these together, what you would get is you would get the amount that you've increased by. And then after, if you multiplied by this, if we knew what that decrease was, then we would have received 55 milliliters per hour. Okay, so let's do it. And so what we have is, so I guess I'm going to work out the brackets, which is 1.15. So 1.15 multiplied by 80. So that's 92. So after the increase of 15%, that means we've increased it and it would have been 92 milliliters per hour. But then, as they said, the doctor, I guess, wants us to reduce it back to 55, and we want to find out what this little d is. So I can divide both sides by 92, or I can bring in this 92 inside of the brackets. Okay, so that's up to you which way you go. Okay, so I'll bring it inside the brackets here. And so that's going to be that. Now, if you do divide both sides by 92, just do keep the decimals over, because you don't want to start rounding there, because it's an intermediate step. Now, within here, if you distribute across, then there's really nothing to keep. You just kind of keep whatever it is that it's showing. So now let me swap. So I'm going to bring this over to this side, this over to this side. Just as I'm solving, 92 minus 55, just if you're kind of worried. So the 92, actually I had that there. So that's 37. So we have 37 and 92 over d. You can divide that on both sides. And that's going to give me now, so it's 37 divided by 92. So 0, 4, 0, 2, 1, 7, and so on. That's in decimal form. Round percent to the 1. Okay, so if you convert this to percent, it's going to be 40.217 and so on percent. But round it to the 1, it's just 40%. So it looks like we kind of had to decrease the medication by 40% in order to bring it down to 55 milliliters per hour. And this is how you can set it up and solve this problem. All right. So I hope that was useful. Okay. So thanks for watching, and see you in a future video. Bye, everybody.